All right, we're going to talk a little bit about compositions of functions, composite functions. And this is the case where you're plugging one function into another. And the notation, like someone said in class, it looks like it says fog to me. So it's something like f of g of x. And you could go, any function of any function. You could go g of f of x. So what you're doing with composite functions is there's two ways to think about it. If f of x is a machine like this, I'm going to plug something into f of x, and out comes something else. And then g of x is just another machine, where again you plug in an x, something happens, out pops a y. What you're doing in this case is you're taking x, plugging it into g. So take x, plug it into g, out's going to pop g of x. And then you're plugging that answer into f. So essentially, you're lining the machines up so one feeds into the other. So it's like you're setting up f of x like that, so that x goes into g, the answer from that goes into f, and out pops after that. The answer that comes out is f of g of x. Look at that, I changed the thickness of the line. So how do we just kind of make this happen? So let's just define a couple. F of x, let's make that 2x plus 1. And g of x, let's make that x squared minus 1. So these are just defined. F of g of x, we'll do both of these. F of g of x. So what this means is f of g of x. So you're literally going to take g of x and plug it into f. So g of x basically says g of some input is that input squared minus 1. So my input's x. So g of x is x squared minus 1. So f of x squared minus 1. So notice now this x squared minus 1 is my input for the function f. And the function f says 2 times whatever the input is plus 1. So like for instance, if I had f of 4, 2 times 4 plus 1. F of 7, 2 times 7 plus 1. I just happen to have f of x squared minus 1. So f is, like I said, 2 times whatever the input is plus 1. Notice that the input takes the place of the x. This x is a placeholder telling you this is where the input goes. So f of whatever is 2 times whatever plus 1. My input is x squared minus 1, so that goes into the input spot. That's plugged right into that expression. So then, distribute the 2, just a little bit of algebra to kind of clean it up. Combine some like terms, 2x squared minus 1. So this is f of g of x. This is what you get if you plug g into f. Now, let's do the other one, g of f of x. So now what we're going to do here is plug f into g. So this is g of f of x. So what is f of x? It's 2x plus 1. G of 2x plus 1. So 2x plus 1 is the input for g. And notice what g is as a function. G of input is input squared minus 1. So g is whatever the input is squared minus 1. And the input happens to be 2x plus 1. 2x plus 1. So that's what it is. So now I'm going to just do a little algebra here, clean it up. 2x plus 1 squared. You might just know it. You could FOIL it out, whatever it takes to get there. But it's going to end up being 4x squared plus 4x plus 1. And notice that's just that part, and that whole thing is still minus 1. So this is just that squaring, and then that squared is minus 1. Combine some like terms, and you get 4x squared plus 4x.